Oh, okay. Uh, okay. Share. Okay, let's go. So, um, last week we finished chapter one, and now I would like to do is I would like to start object-oriented principles. Okay, so let's do that. So basically, the idea is like this. I'm trying to think if it's easier to do the code first or the. I think code is easier. Okay, because it's more, you know, it's more it's more what's the word? It's more, it's more like you could see it. So actually, I'm gonna create a new project in a second. Let's see if we could figure if I can remember what I did before. Okay, I did this earlier today. So let's do object-oriented principles and spring 2026 lecture. Okay, so let's let's look at this. Okay, because I don't want to assume that you know anything about Java, so we'll take it slow. Can everybody see the board? Should I turn off the light? I don't know why it seems like it's a bright light. Okay, so first let's do inheritance. Okay, everybody familiar with this? Let's just review inheritance. Okay, so inheritance is, does anybody know what is inheritance? You know what is inheritance? Okay, inheritance is basically you have let's do it. Okay, we'll do it. So let's have um, a parent, let's say a parent shape, and let's say the parent shape, let's say has a method called draw, right? So we'll just do a void draw, and it's going to print out, um, I don't know, drawing this shape. Sure. So it should say drawing parent shape, drawing the parent shape. Okay. Let's say the parent shape, let's make it uh, more, let's say drawing a, okay, let's just say parent shape. So, so then we could have, let's say, a circle, right? Okay. So let's say we have a circle class, right? So, and then the circle class, let's say, wants to reuse the code, right? So instead of figuring out how to do it, the circle class could what? What could it do? Right, it could use it from the parent, right? Or like you said, extend. Right, so we could do extend parent shape. And then, for example, we could have other things that, I don't know, whatever, a circle, let's say, returns um, let's say it returns what is the area of a circle? Um, I'll just make up something. So was it pi r squared? So um, let's say the radius is, I don't know, whatever. So um, int radius uh, there, whatever. So it returns something. Returns let's say radius um, was it pi r squared times radius times pi. Uh, I don't know what it is. Math. Maybe it's math.pi. I'm just guessing. Pi. Uh, let's see. Let's look it up here. Java uh, pi value is the math. Oh, I was right. It is pi. Math is close. It's capital Phi. Okay, so let's say this works. I don't know my math so well, so, and it doesn't like, okay, it doesn't like, okay, so it wants to be a double. So let's make this a public. Okay, so, int, oh, it should be a double, sorry. Okay. Okay, so we have the area method over here, right? And I think that's good, right? Pi r squared. So, and then maybe the constructor will do, I just want to do something that's specific to a circle. And then maybe we'll do for the circle, we'll pass in the radius. Actually, let's just leave it like it is. Okay, so, actually, let's pass it in, why not? Make it more realistic. So, we generate the constructor, pass in the radius. Okay, very good. And let's make this a double just for the fun of it. Okay. Um, and then in main, since remember the main thing to remember that circles inheriting parent shape, right? So in main, not only do we have the area method, right? But we also have what? We have we have two methods, right? One which belongs to circle only, which is area, and then another one which inherits from parent shape, right? So, so in main, we could do something like circle, whoops, what was that? Circle, that circle equals to new circle, and then we could do something like circle dot draw. Okay, so good. So now we could reuse. Oh, we have to pass in radius. Let's do one, and it doesn't like that. When cast argument to end. Huh? I thought it was a. Oh, huh. Okay, sorry about that. Okay, now we go. Okay, so over here, we now we could draw it. So if we draw it now, we're still doing the parent draw, right? Um, okay, so even though we have our own, this is inheritance, right? So circle is using has its own, so some of its own things, and some of it whatever gets from its parent, right? Okay, so. Um, so this is one way, this is what they teach you in, I don't know, the first class object-oriented program, right? To use inheritance. And then the problem is, wait a second, I want to draw my own circle, right? So what do you have to do? If you don't like the way the parent is doing it, what do you do? Let's say I want to have my specific drawing of a circle. What do you have to do? Right. So you take, right? You actually in Java, you don't even have to say it. You could just go into circle and then you could uh, have a method called draw in drawing a circle, a round circle, right? A round circle. And now, so instead of inheriting the way the drawing from the parent, now instead it's doing it from it's doing its own, right? So now you'll see it's going to draw a circle, right? Because we overrode we gave our own circle. So the way inheritance works is if we don't provide it, we get it from the parent, right? Or or if we do provide it, we override it. Okay? That's that's object-oriented programming, right? Okay. Now there's another two ways we could do this. Okay. Before we do that, let's just create another class called a square. And just want to have that. Also, I'll just, actually, I'll just copy circle class and I'll just paste it in. So I'll just go here, change the name to square. And it's going to have a, I have to change this. And then the radius is going to be, well, doesn't really make sense that we're erased, but we'll just have it, for area, we'll just do radius times radius. Okay, so this, and then drawing a square. Okay, so now we so now we have, so we have a circle and a shape, right? They both inherit from parent shape, right? Now, one thing that's cool we could do is we could actually treat that, since they both inherit from the same parent, what could we do? We could actually do something like this. We could do something like, so let me just comment it out for a second. I'm sorry? So we could, are you familiar with this thing? This is angle brackets, right? So then what that means is it's actually, I mean, it's new for me sort of. It's like a template object, a template method. I forgot what they call it, generic. I'm not sure what they call it in Java, but in C++ it's called template, right? And so basically you could pass it a type rather than having to, and this way it's like it'll do type checking, but you don't have to write a whole new object every time you use it, right? To just pass in the type. So over here, let's pass in parent shape, and list is a I have to tell to use the list, Alt plus Enter. So that would be that. I did Alt plus Enter. Alt, oh, Enter. Huh? What that wasn't good. Uh, there we go. Okay, so we could say um, uh, list, and then, okay, don't get confused about that. So now we could do is we have a list of parent shapes, and we could add, since both square and circle inherit from parent shape, we could do something like this. We could add new circle, and we could pass in, say, 1, and we could do list dot add new square, and that could pass in that, okay. And then we could go through the list. We could say list for each shape. So we do S. I think you do like this. We do S, and then we do, what is it? Yeah, I think it's like for each, maybe it's this, S, we do S dot draw. Okay, so this is just something that we do at work, which is just it's doing a for each loop on a list. We're just calling a method, which does the exact same thing. So it's the same as doing a any for loop on any list of things. And this is, you're just passing in, just going through the list, and we're calling draw on each one, right? So we could actually call this, and then we could add um, and then we could do, okay, let's just try this. Okay, simple enough. So, and the reason we could do that is because, um, okay, so it's doing a round circle and it's drawing a square, right? So it's good, right? So, okay, so this is all using inheritance. Okay, so what's wrong with this, right? So the answer is that every time we change this method over here, and there's, let's say, for example, um, let's say, for example, this would use, let's say, method um, A, okay, and this does something, I don't know what it does, right? And then we would have another one called method B. So, um, actually, you know what, let's leave it out. Okay, so actually, before I do that, let me just, okay, so this is one way to do it, okay? So far, so good? We're good? Okay, let me just shrink that. Okay, so this is, now the problem with inheritance is that it's tightly coupled to the parent, okay? Which means that when anytime I mean, over here, so for example, over here, we could have done something like, or typically you'll see something like this. You'll see something like, you'll use the parent class and then you'll call in other words, when you do when you do, before you do your own draw, you do the parent's draw. No, you're still going to reuse some of it, right? No, this case isn't a great example because over here I don't have that much going on. So I'm overriding the only thing that I'm inheriting, I'm doing differently, right? But normally what happens is that the point of inheritance is to reuse something from the parent, right? I don't want to just do because in this example over here, I'm not getting anything from right? If I take this out, I'm not really getting anything from my parent, right? I'm not using any code from it. So typically you would use something from it. And the issue with that is that when I would change, let's say when I do the square, let's go back here for a second. So when I draw okay, so when we do when it's drawing the square, it's also using the parent shape method, right? Maybe we should make it a little better. Drawing the parent, I'd say, calling the parent shape draw. Okay, it'd be less confusing. Okay, um, so over here, the square is using the parent shape. And the problem is that whenever you change the parent shape, it's going to affect the square, right? How that draws, right? So they're very, um, I don't know why it keeps doing that. It's so weird. I'm just trying to click it. Yeah, so every time I change the parent, I'm going to affect the drawing of the square, let's say, okay? Because typically that's what happens, because otherwise, why do you have inheritance unless you're going to reuse something from the parent, right? But the problem is that every time I change the parent, look at all the children I have. I have circle, I have square, I could have other shapes, right? I could have diamond, etc., right? So every time I change the parent, there's there's a possibility that I could I could break the children. Okay? If the, in other words, if like in square, if they're using the parent, right? When they draw, they're using something from the parent. So when I change the parent, it could affect multiple children and then down the line, grandchildren, stuff like that. Okay, so it gets it is so let's see if there's a different way of doing it. Okay, so is there another way to draw without doing inheritance? Okay, so I want to present you another way of doing it. Okay, so this is another way we're going to do it. So this is a class called Draw Shape. Basically, we're going to see three different ways of doing it. Okay, one way we just saw how to do it, right? We have Draw Shape, and we draw shape rather than inheriting. is going to have circle inside of it. And it's going to have square inside of it. Oh, I forgot to put a thing there. And then let's just do the same thing. And then we have, let's say, a method called draw, and draw is going to take a thing called shape and capital S in Java, and can say something like this. So if shape dot compared to, let's say, circle equals to 0, then to circle dot draw. And then the same idea with square. So what am I doing over here? Over here, okay, what I'm doing now is I'm having one method called draw, but what I'm going to do is I'm going to uh, so I'm going to um, um, what I'm going to do is, in other words, rather than inheriting, I'm going to have what's called composition. Okay, so this is called composition. So instead of uh, in other words, in this example, a square and a circle, they inherit from parent shape. So remember over here in main, not only since they inherit from parent shape, they actually are a parent shape. In other words, when you inherit in code from something else, you actually are the thing you're inheriting from, right? In other words, every circle and every square is also a parent shape. That's why we were able to treat them the same, right? Another way to do it, though, is rather than becoming a parent shape, what we could do is we could put them inside another object called draw shape, and then so rather than inheriting, we're going to just have them inside, and then we use them as we want. Okay, that's called composition. Composition is really just a fancy way of saying that we have another object inside of us, right? We're composed of other objects. So, so now draw shape is free to do whatever it wants. It's more free, no, it's circle and square are both, let's look at square, for example. So square is every time we change the parent, it's going to affect its draw method, right? It might, right? It might, in other words, every time we change the parent shape, it might break a child that uses part of it, right? So it might break square, right? Because square is using the draw from its parent. Does that make sense? But over here in draw shape, we're basically saying that we don't need inheritance. Rather, we have them inside of us, and we're going to use them the way we want. Um, okay, this example doesn't. Okay, so well, let me get to the next, and then the third way of doing it. Okay, because this is not a great way either. Okay. Um, does anybody see a problem with doing it this way? Like, what would be the problem with this? This way. There's another way to draw the shapes, right? Um, and then, for example, we would have something like this. We would have, let's say, we would have uh, a list of we could do something like this. We'd have a list of strings, and then a list two, and that could be, and this would be list two that add, and we would add circle, and then we would add square, and then we would do something like for, we do the same code, and we would do something like for each string, we would call, oh, I would have to do declare draw shape. And then I would just call draw shape dot draw, and I would pass it the shape to draw. I think I did I do that right? Is that an error or? I don't know what that means. Let's try this. I'm not familiar with that. Okay, so over here, will it work run? I'm not sure. Let's see. It doesn't like it. Okay, it runs. Okay, so over here it's doing the same thing twice, but it's doing it a different way. So over here we're just passing in, we have one method, and based on whatever this argument is, the draw knows which object to use. Okay? This is not a great way to do it. Why? Because obviously every time we add a new shape, we're going to, in order to draw it, we have to change this code. Okay? That's not a good way of doing things, right? So, so let's come up with a third way. So a third way of doing it is what's called an interface. Okay? Are people familiar with the interface? Um, okay, so I didn't really use it much before I taught this course, but it's really for object-oriented programming, it's really cool. Okay, so what an interface is, it's an object which has no code. It's just a definition. Okay, so basically, if you think about it, in other words, um, like how do you group things together? Like one way to, in other words, in programming, how do you make things associated with each other, right? So one way is if they have a common parent, right? But but we said that that's maybe a little bit too, um, the word is coupled. There's too tight of a relationship between the parent and the child. So is there another way that we could treat different types as the same type, the same? That's the question, okay? In other words, one way is to become the parent, right? If you inherit, you are the parent. So of course you're associated with all your siblings, right? Because you all have a common parent, right? So you all have the parent methods, right? That's one way to associate different objects, right? You inherit from the same thing. But we say inheritance is very strong of a way to be related because when you change the parent, you change the children, right? So what's another way? So another way to do it is to what's known as inheritance. Inheritance is like is basically saying so let's say, for example, let's say you have a restaurant, right? Now, there's two ways you could advertise. Let's say you need a cook for your restaurant, right? There's two ways to advertise, right? One way to advertise for the cook is to say you need somebody who's 6 feet tall. They speak I don't know, they speak French, and they I don't know, whatever, the different characteristics. Maybe it has to be a female, maybe it has to be a male, whatever it is, but you give a whole bunch of requirements. They really have nothing to do with the job, right? So you say they have to be French, they have to be 6 feet tall, female, male, and they have to, I don't know, have red hair, right? Those are job requirements. So every time you add another requirement, what happens? The list of applicants to this job decrease, right? Because as we increase the requirements, right, there are less people that match it, right? But but let's say, for example, we say that I just need somebody who knows how to cook a omelet, and that's all I'm looking for. I don't care the red hair, black hair, brown hair. All I care about is that what they could do. Could this person be male? I don't care if they're male, female, short, tall. All I care about is could they do this job? If they could do this job, if they know how to cook breakfast or cook French food, whatever they could do, whatever I need, if they could do that, I don't, that's all I care about. So now, obviously, I'm going to have a lot more people that fit that position, right? Because it's much more broad, right? So that's what interface is. The interface is saying that I'm grouping things by what they do. As long as they do what I need to be done, then I could group them together. So let's say, for example, I have something called a interface called shape. And then for shape, I'm not going to put code in here, but rather all I'm going to say is what I need it to do. So if you're a shape, I'm going to say that all I need it to do is to draw. And that's the only thing you have to do. Okay. So now what we could do is we could we could say that um, rather than inheriting it, we could, rather than force the children to inherit a specific code, right? Instead, the people, the methods that implement shape are going to just have to do one thing, to at least one thing, which is going to be to draw. So, so example, let's say circle, I'll call it circle, um, let's say circle using interface or implement it. I don't know. Circle with um, uh, no, the circle from shape, let's say. Maybe that's better. Circle from shape. And basically, this is going to implement. So it's going to say that, and I don't know why that is, it's going to implement shape. So if it implements shape, that means it's advertising that it knows how to um, it knows how to draw. So um, that's the only thing that circle from shape needs to do is I wish I could bring this down a little bit up. Why? I don't know how to get rid of that. Oh, that's why. Okay. So why is it? Okay, okay. How do I get rid of this message? It's annoying. Uh, okay. So over here, now I'm just going to do, okay. So now and then we could have, let's say, for example, we could have square from shape, square from shape. And this is also going to implement shape. And it's also going to draw. it's gonna, because it advertises itself as implementing shape, here, so you can see better, right? So therefore, it has to have a draw method, which we're gonna put over here. And this is going to be drawing a square. Okay, and now we could actually, without inheritance, we could treat them as similar, right? Because remember, what do they have in common? Right? What is circle from shape and square from shape have in common? There's only one thing they have in common, right? They what? They implement shape. They do everything that shape requires, and the only thing shape requires is to have a draw method, right? So now we could treat them the same, but without forcing them to inherit from. Notice over here we were able to treat them the same, but we had to use inheritance, right? We had the circle had to inherit from parent shape. That's how we got them to be the same, right? By using inheritance. But another way to do it is we could do something here. We could do something called list of, and we could have list of shape and list three. And over here we could do list three dot add, and then we could add a new circle from shape, and we could add a new square from shape, right? So see, we could treat them the same because they not because they inherit, but because they implement the the shape interface. Okay, so basically, it's like saying like you go to an airport and like everybody who's who has a airline, I don't know, hat or a pilot hat, we treat as a pilot, right? We let them into, get into the pilot lounge, whatever, right? Because they have that uniform, they advertising that they know how to fly an airplane, so we let them fly the airplane. Do we really know? No, but that's what they advertise, right? They're wearing the hat that says that they're a pilot. Here also, the circle says, I implement shape, so I know how to draw shape. And the circle, the square from shape says, I also implement shape, so I know how to draw. So and now we could do is, over here, inside draw shape, we could actually have another method, which is going to be really simple. And this is going to be also a draw method, but it's going to take, guess what? It's going to take as a parameter, it's going to take a shape. So any shape it will be able to draw by calling shape dot draw. Okay, so over here, we could, back in main, we could have, so for every shape over here, we could call shape dot, okay, that's cool. So it actually is going to call the right method. Um, so it's going to call, instead it's going to pass in the circle. Here, let me just for a second, let me just comment this out. And I commented out draw a shape. I didn't want to do that. So over here, we could run this like that. Okay, so over here, we were able to have one method called inside draw shape called, and this is basically whatever shape we pass it, it knows what to do with it. Okay, because it takes it says anything that has the shape, the draw method, right? We know what to do with it. We know how to draw it. Okay. Okay, so just to summarize what we did. So, okay, I know I did a lot, especially if you're not familiar with all these concepts. But basically, I'll try to go over it really quick. So basically, over here, first thing we did was we we'll start at the beginning. First, we started out with regular. This is standard inheritance, right? Right. We showed how to use standard inheritance and standard inheritance, it works because we're able to treat circle and square as the same, right? Because they are parent shapes, right? Right. So circle and square are the same, are treated the same because they have the same parent, right? The same parent. And presumably and probably use some of their parents' methods. Okay, so that is the first way. This is the stand. This is what they teach you in regular, um, in regular um, object-oriented programming, right? And they'll teach you to use inheritance, and then you could treat them the same, and then, okay, this works. Next, okay, so that's one way to do it, okay? But remember, what's the problem with this way? Um, okay, I'll put that in a different document. I don't want to, okay, so this is one way to do it. A second way to do it is to, to have a composition which means that um, the objects are within within another object which controls them. Okay. And so that's way B. So way B was that the second way was that we had this draw shape over here, and there was this method over here, which based on the value passed to it would do what we asked it to do. Okay. That's way number two. Okay. Following? So way number one was we have the different objects, they're treated the same because based on who their parent is, so we just pass in one at a time. The second way is we just we just have one method, and this method decides based on the string what to do. And the third way to do it is that we basically create a group of objects by by just by we group objects together if they have uh, a certain function methods our functionality. Or another way of saying that is, i.e., they implement the interface. Okay, so basically there's three ways to do it. We could treat them the way what they do, who they are, which is number one, or the middle way was we just pass in a request and it does what we want it to do. We don't know about inheritance. We don't, right? We just pass in, draw a circle, draw a square, and then we let the object decide what to do. Now, which way is the best? Well, the answer is going to be number three, and you could and I'll just show you real quickly. Well, the problem with this is the first way was because with regular inheritance, the problem is that when you change the parent, you could break the children. So even though it works out well in this case, but in real life where you have more complicated when you have like, imagine you have a company where people have been working at it, where you have let's say you have five programmers, right? You have five programmers and each programmer works, let's say 7 hours a day, and you multiply that times a whole year, you can imagine the amount of code that that's going to be produced. So you can imagine how complicated the parents are going to end up being, right? So if you have these children using their parents and you have complicated objects and you have children of them and then you change the parent, guess what happens? Pretty often when you change the parent, you're going to break the children, right? Because you might be making a change for one child, but you don't realize maybe it's a grandchild somewhere, or so when you use inheritance, there's a very good chance you're going to break the children. So we don't like using inheritance, even though they teach it in computer whatever 102, whatever the object-oriented thing they teach it to us, but it's actually in real life. I know where I work, like whenever we're dealing with inheritance, it's very scary because you might be breaking something and no one's going to notice it for like, till it, gets, released. So because you don't know exactly what's going to happen when you change something when it has a lot of children, right? Because then you have to see how it's being used by all the children. And that's a pain in the neck, right? So it's scary because how are we going to test for all the different, what that change might have done to all the children? So basically, even though it works out well over here, but it's too strong of a relationship to be good in real life, because in real life, when you have a complicated parent and complicated children and grandchildren, and we're going to do what's called the strategy pattern. We'll see it. We'll actually see a good example of that. But we'll show more in more detail. Okay, and then so that's why number one isn't that good of idea. Number two is a bad idea because even though it's not using inheritance, but every time we have a new shape, look what happens. We have to change this code over here, right? So that's not so good, right? So we got away from inheritance, but we're stuck with modifying code. That's not good, right? And also, anytime you see a lot of if statements, that's not good either, right? Then there's a good chance something is going to go wrong, right? Anytime you see complicated, like if this is true, I mean, a lot of programmers, they like to cut corners and they make complicated if statements instead of, redoing the code. They'll just keep adding conditions, say, well, when it's this, do this. When it's this, when it's A and not B and C, do this, right? And after a while, the code gets really crazy and you end up having bugs. So the third way to do it is over here, where all we're doing is we just this code is not going to change, meaning that when we add going back to main, right? The draw over here, all it's doing is it's calling the draw method that each object has. right? But but they're not they're associated not on who their parents are, but what they do. That's the third way. Okay. How's that sound? So the third way is we're associating them based on what they do, which is they draw, and that allows us to to pass them into this method over here, which takes it takes any object, it doesn't care who it is, as long as they have a draw method. That's all. No, the only thing I could do over here is draw. I don't know anything else about the objects being passed in. See, there's nothing else I have. Well, the only method I could do is draw, but that's the only thing I want to do. So since all I'm interested in drawing is, so this is going to be, this is never going to have to change, right? As long as the objects that are being passed into me have a draw method, right? Just like when you hire a cook, as long as they can make French toast or whatever for breakfast, that's all I care about, right? So I'm not going to have to, know if I can't find a cook, I mean, my cook quits on me, I'll just look for another cook that knows how to do the exact same thing, making my French toast. So over here, any object that has a draw method, that's the one I want, and that's the one that's good for me. Okay, so this is the third way, turns out to be the most sustainable way of doing it. Okay, because again, the first way was inheritance, which we said in the long run becomes very complicated because of the strong attraction, meaning it's what's the word is tightly coupled, meaning that if you change the parent, you're by definition changing the children, right? The second way we said is not inheritance, but it's messy because every time we draw a shape, we're going to have to modify every time we do a shape, we're gonna have to modify this method. And the third way is it hits the sweet spot because it allows us to treat them the same, but only for what we need it for, which is that they implement the draw method. But that's the only thing we're going to, that's the only thing we're looking for. Okay? So, so I wrote this up in a document. Let's look at this a second. So, okay. So, um, okay, so basically, this is what a UML stands for Unified Modeling Language, and um, it's a whole crazy history why it's called Unified Model. It used to be that there was different competing models, so the four big people got together and they created one common way of doing it. So basically, what is UML? UML is basically there's a program here called I have on my machine, which is free, called um, Visual Paradigm. And basically, it allows you to create different diagrams. Um, and a diagram is just a way of a quick way of representing an object. So I just want to show you just a very. I'm not like gonna dwell on it. Just want to do. So for example, let's say I do a new um, a new diagram. So there's a lot of different UML diagrams you could create. These are all free. I think there's more if you pay for them, right? But this is the only one right now I want to look at, which is called a class diagram, right? And within this class diagram, we could basically do is create a I don't know what makes me do that. Um, let me just get out of this. By the way, it's also web-based, so you don't have to use this, but it's free. So if you want it, so let's add a class. Okay, let's make this bigger so you can see it. Um, a little bigger, come on. drag it over here, a little bigger. Okay, so this is, let's say, let's do, for example, our circle shape, or just let's create something. So over here would be the name of the object, and then and besides being be having a name, right? We would have there's two parts to every object, which is the two possible parts, which is we have what's called over here they're calling it operator attributes, which is basically a property, whatever that So for example, like radius would be a property of a circle. And then it would have, let's say, it could have a method. So if we do right click, you would add a operation, they're calling operation, which would be like draw. Okay, so this would be a typical object, right? So that we have it has basically only two things, right? It has data and it has methods, operators, right? So draw would do an operation and radius would be what it stores. Okay, so so going back over here, so over here, for example, we have the data, which would be the date of the order and the status. And then over here would be the four different methods that would come with it, that this object would have, right? So, um, so that's basically what I'm showing over here. Okay, so that's basically when we already covered that. And then, and okay, here I asked, what is an object in Java? The answer is a class is basically an object. Um, oh, I forgot this part. Um, now, um, over here, what's interesting is that, um, in other words, all these objects we created, right? If you look at them, they have code, right? There's code here, right? Or they inherit from something that has code, right? So, but what about shape? Shape doesn't have code, right? It just has a description of what it could do, right? There's no code over here, right? So the question is, could we create an object called shape, right? So in other words, I could create a list which takes shape, but could I create an actual shape object? So could I go over here and say, for example, shape equals to new shape. And um, it it nope, yeah, I can't create it. Why? Because it could refer to a type, but you can't actually create it because it has no code, right? Look at it. There's nothing here to create, right? There's no object, there's no method, right? It's only description of what a shape object should do, but there's nothing to create. So you can't create it, okay? On the other hand, over here, or back over here, let's say I could refer to an object if so in other words, let's say no, on the left side, I could refer to something as a shape if on the right side it has code. So over here, it has code. So I could do new and create it, right? But but I could refer to it since it implements the shape, I could put it on the left side. Does that make sense? I can't create it using the new on the right side, right? Because shape doesn't have any code. I have to do something that actually has code in it, right? But since it implements shape, I could point to it, right? So I could use it on the left side. Okay, so so this is okay, right? So I could do something like since this I could do something like this shape dot draw because since on the right side I have a real object, so on the left side, therefore I could refer to it over here. I could point to it, and then I could call the draw method of this circle. Okay, is that okay? So, um, so now, let's say, okay, let me ask, now let's say I do this. This is, let's say I do something like this. Um, is shape and shape one, are they pointing at the same object in this case? Is it hard to see? Are they pointing at the same object? Could you see?
I think so.
What?
I think so.
They are? This point is the same type, but it's actually two different objects, right? Because one object was over here, and this is this object number two, right? In other words, they're both, I created two objects in memory, right? One is this one over here, and this over here. So they're the same type. They're both shape objects, but they're actually two different, right? It's like um, if you have, let's say, two dogs, right? They're both the dogs. Each one is the same type as a dog, but you have two of them, right? Here we have two shapes, but they're two separate ones, right? Because every time we do the new operator, we're creating a separate object, a new object, right? So memory, like we don't really have memory in Java, but but we do have two different objects, right? We did create one object over here, another object over here, but and so um, we're okay, so but and we cannot create this object, the shape itself, right? Because the shape itself has no code. Okay, so we said a class. Okay, so we said so the question is, what is the difference between a class and an instance of that class? Okay, so we just explained that, right? So a class is a type, right? Like a type of object, but it's an instance is when you actually create that object. So that's like an actual, like two pairs of shoes, right? Or two shoes, right? So you might have a shoe type, but if you have two of them, you have two shoes, right? So you have two instances of a shoe, right? If you order 10 shoes, right? You have 10 physical shoes in front of you. They're all type of a shoe, right? They go in your shoe rack, but they're physically, they're actually different shoes, right? You can have a red shoe, blue shoe, white shoe, etc. Right? So that's the difference between a class and instance of a class. Class is just like what type it is, but instance is the actual object. Okay? Good? Does that make sense? You look a little unsure. Should I repeat it or? Um, okay, um, so basically the way you could do it is, so there's basically only two type, one way of looking at classes is to see could I use the new operator on it. So for example, over here, I could use the new operator on this, but not on this, right? And so therefore, since if I could create a actual object, this is what's known as a concrete object. Okay? Meaning that it's an actual object that exists by itself in memory. And if I but if I can't create it, it's known as an abstract object. It's called an abstract type. Okay? Okay, so that's a simple way of knowing if an object is concrete, right? Or it's abstract. If you can't create it, then it's abstract. If you could create it, it's called a concrete object. It's like a real object because it has code that it could be created. Okay. Um, okay, I forgot to take attendance. Is anybody I forgot to take attendance from? Who's here today? I just want to check the attendance. Uh, and I don't know where it is. Uh, Oh, here it is. Oh, I just saw it back here. Here we are. So, anybody here that I haven't marked here yet? Yeah, which line are you? Oh, okay, great.
Professor,
Yeah.
could I do the same as well, actually? I was gonna mention it after class.
Say again?
Uh, could I have mine marked up as well? I was gonna mention it after class, but
Which line are you?
27 or 26, sorry, 26.
Okay. Are you related to the other person? Oh no, oh
No,
yeah, you're related to this person? No, no, it's a different name. Sorry.
not at all.
No, 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 this person. Okay. Okay. Um, okay. Yeah, anybody else? Yeah,
Me too.
35. Okay. And who else? Anybody else here?
Um, um, Me too. Fariha Wahid.
Oh, you're 31? Right. What you're Faria, right? I think it's right.
Yes.
Yeah, okay, good. Okay. So, okay, we're filling up the thing. So we're only missing two people, I think two people. Yeah, two people, three people. Okay. Okay, hopefully we'll fill it up. Okay, great. Okay, so I'll see you on Thursday, and you'll see. I think they're gonna fall into place. I did the hard part. We got it over with, and then you'll see we're gonna go over this over and over again. You'll see till you'll at the end of by the end of the semester, you'll know interfaces. You'll be expert in it because we use it. We're gonna be using it a lot. So, and you'll get really good at it. You'll see. Okay, we're going to do not now, but we're going to do the strategy pattern. When you do that, you'll really understand how interfaces work and composition and why we don't do inheritance. Um, okay, have a good evening. I'll see you Thursday night. Okay, and please have those presentations coming. Okay.
Have a good one, Professor.
Okay. Good night. Goodbye. Okay. Good night.